In this video, I will show you how to solve systems of conic sections like this one. Conic sections are circles, parabolas, ellipses, and hyperbolas. The top equation is a parabola. I can tell because only one variable is squared. The bottom equation is also a parabola for the same reason. Only one variable is squared. So we have a parabola and another parabola. It might look something like this, and we're looking for the intersection points. So when you solve a system, you're going to use either substitution or elimination. If I don't see an easy way to do substitution, then I try elimination. So you just have to decide which one looks easiest for that particular problem. Now, keeping in mind that elimination is all about finding opposites that cancel, elimination is going to work pretty well on this problem. Imagine that we multiply the bottom equation by -1. I'm looking at the x squared and I'm looking at the y terms. If I multiply by -1, these will become opposites. So this equation will become -x squared plus 11x minus y plus 23 is equal to 0. All the signs changed. Now I have not done anything to the top equation, so I'm just going to recopy it unchanged. So I've got x squared minus 6x plus y minus 13 is equal to 0. And I want to combine like terms. Well, the x squared will cancel out, and -6 and 11, that's going to make 5x. The plus and minus y will cancel out. And here I will have 10 is equal to 0. This will be easy to solve. Subtracting 10 from both sides, I have 5x equals -10. Dividing both sides by 5, I have x equals -2. Alright, so as I think about my solution set that I'm aiming for, here's what I have so far. Since I have an x value of -2, that means I have -2 comma something. I just need to find the y value that goes with this x value. So I can find the y value by taking this x value and substituting it back into one of the original equations. So I'm just going to use the top equation. So I'm going to let x equal -2. And I'm using the top equation. So if x is -2, then I have -2 squared minus 6 times -2 plus y minus 13 is equal to 0. So this is 4 plus 12 plus y minus 13 is equal to 0. 4 plus 12 is 16. Minus 13 is 3. So I'm going to have y plus 3 is equal to 0. Subtracting 3 from both sides, I have y equals -3. So now I have my x value and my y value. Okay, so this is the solution. So let's check Desmos.com and see what these two parabolas look like, and let's see if we can find the intersection point at -2, -3. Okay, here are the two parabolas, and it looks like they intersect over here somewhere, and here's the intersection point right here, and guess what? negative 2 comma negative 3. The exact value that we found when we did it by hand. In problem number 11, the first equation is a circle. I can tell because the x squared and y squared both have the same coefficient, 1 and 1. The second equation is a hyperbola. I can tell because the x squared, it has a positive coefficient, while the y squared has a negative coefficient. Let's solve this system and find out what the points of intersection are. But you're talking about a hyperbola and a circle, so it's something basically like this, and we're looking for these intersection points. So we have to decide, will we use substitution or elimination? A problem like this is perfect for elimination. Well, first of all, it would be really tough to do substitution, like which variable are you going to get by itself and then plug into the other equation. But also, the y squared and y squared, they're already opposites. We don't even have to multiply by negative 1 or anything. I can just start combining like terms. So if I combine these, that's going to make 2x squared. These cancel out. If I combine these, I get negative 20x. If I combine these, I get positive 50 equals 0. I couldn't help but notice that all of these are divisible by 2. So let's go and divide everything by 2. To make the numbers smaller, let's make life easier for ourselves. So then we have x squared minus 10x plus 25 is equal to 0. This looks factorable to me. X squared is going to be x times x. 25. I'm going to go with 5 times 5. If these are both negative, that'll make negative 10x, so we're good. We can find the solutions by setting these equal to 0. There's no point in setting the other one equal to 0 because it's the same. If I add 5 to both sides, that's going to give me x equals 5. So, as I contemplate my solution set, here's what I have so far. 5 comma something. I have the x value, but I need the y value to go with it. So, how will I find the y value? I'm going to take this x value and plug it back into one of these equations. I might as well just use the top equation. So let's let x equal 5. So taking this top equation, I've got x squared, so that's going to be 5 squared plus y squared minus 2 times x, so 2 times 5, minus 15 is equal to 0. So that's 25 plus y squared minus 10 minus 15 is equal to 0. Now these together, negative 10 and negative 15, that's negative 25. So look, I'll just do it. So I have 25 plus y squared minus 25 is equal to 0. But these are going to cancel each other out. So I really just have y squared is equal to 0. Taking the square root of both sides, I have y is equal to 0. So this is the y value that goes with this x value. So that's it. 5 comma 0 should be the intersection between the circle and the hyperbola. I'm really curious how a circle and a hyperbola will wind up intersecting at exactly one point. So this should be interesting to see. Let's take a look at Desmos.com and see how that played out. So take a look and behold. You see the blue hyperbola and then the red circle. And they seem to be touching just at this one point right here, the point 5 comma 0, the same point that we found when we solved this by hand. That is pretty neat. I know what you're thinking. Can we please do one more? Well, sure, why not? The first equation is a parabola. I know that because only one variable is squared. The x is squared, the y is not squared. It's a parabola. The second equation is an ellipse. I know this because both x squared and y squared are positive. They're the same sign, but they don't have the same coefficients. One is 9 and the other is 1. So that's an ellipse. If they were both the same, like 9 and 9, that would be a circle. So fine, I have an ellipse, like one of these, and a parabola. I don't know exactly how it goes, but we're looking for the intersection points. We have to choose between substitution and elimination. And there's no contest. Obviously, elimination is going to be the way to go. It would be really, really awkward to try to get one of these variables by itself and plug it back into the other equation. Elimination is about creating opposites that cancel. Notice the x squared and the x squared, those are the same. Notice the negative 10x and the negative 10x, those are the same. When you see terms that are the same, you should be thinking, if I multiplied one of those equations by -1, everything that was the same will become opposite. So what I'm going to do is I'm going to multiply by -1, and then I'm going to just, because I don't have a lot of space over here, so I'm going to write the new equation underneath. So if I multiply this first equation by -1, I'm going to get negative x squared. Then I'll get positive 10x and negative 4y and negative 13 is equal to 0. Okay, so I'm sort of getting rid of that old equation because I've now turned it into this new equation. So now that I have opposites that will cancel, I'm going to combine like terms. So these will cancel just like I wanted, and so will these. So that's going to create a new equation, 9y squared minus, those cancel, sorry. So I've got 9y squared minus 18y minus 27 is equal to 0. Now, I can't help but noticing that all three of these terms are divisible by 9. So we should definitely do that to make the numbers smaller and make life easier for ourselves. So that will leave me with y squared minus 2y minus 3 is equal to 0. This looks factorable, wouldn't you say? Y squared is definitely going to be y times y. 3 can only be 1 times 3. If I let this be positive and this be negative, then that will give me negative 2y in the middle. So I can get solutions by setting each of these equal to 0. So I need to set y plus 1 equals 0 and y minus 3 equal to 0. Subtracting 1 from both sides, I get y equals negative 1. Adding 3 to both sides, I get y equals 3. Alright, so negative 1 and 3, you say. Off to the side, let me begin to create my solution set. So here's what I have so far. Because of the negative 1, that means I have something, comma, negative 1. Because of the 3, that means I have something, comma, 3. I have these two y values, but I need the x values to go with them. So how will I find the x values to go with these y values? I need to pick one of the original equations and substitute these y values back in and see what I get. Alright, so for example, we can let y equal -1. I'm going to use the top equation, the one I drew a line through. So let me erase that line so you can get a better view. But everywhere you see a y, I'm going to put a -1. So this equation will become x squared minus 10x plus 4 times -1 plus 13 is equal to 0. So that's x squared minus 10x minus 4 plus 13 is equal to 0. So that's x squared minus 10x plus 9 is equal to 0. Just combining like terms here. This looks factorable. Yay! X squared will be x times x. 9 could be 9 times 1. I'm picking that because of the 10. If I make both of these negative, -9 and -1 make -10. And when you multiply, you get +9. So there you go. Now x minus 9, I'm going to set both of these equal to 0 to find the solutions. So x minus 1 is equal to 0. Adding 9 to both sides, I get x equals 9. Adding 1 to both sides, I get x equals 1. Now, I had one y value, but now I have these two x values. So what am I going to do about that? Well, I'm going to need to write this y value twice. Okay, so alright, so I have something comma -1 and something comma -1 again. I had to write it twice because this one y value gave me two different x values. So I have 9 comma -1 and I have 1 comma -1. Alright, so that's it for the y value of -1. Now let's go ahead and do the same thing with a y value of 3. Okay, so I'm going to come down here and say let y equal 3. Okay, so I'm going to kind of just use this as a guide, remembering that this was the y value right there. So everything else should be the same. So I have x squared minus 10x plus 4 times, here it comes, 3 plus 13 is equal to 0. That's going to give me x squared minus 10x plus 12 plus 13 is equal to 0. That's going to give me x squared minus 10x plus 25 is equal to 0. This looks factorable. X squared is x times x. 25 could be 5 times 5. If I make them both negative, I'll get the -10 and the +25. So, setting these equal to 0, I'm going to have x minus 5 equals 0. Adding 5 to both sides, I have x equals 5. So, for a y value of 3, the x value is 5. Whoops, too far. Okay, so the x value is 5. So this is very interesting. Alright, this is a rare time that I'm seeing 3 solutions. I can't wait to see how this parabola and ellipse intersect in such a way that I get 3 solutions. Let's look at Desmos.com and see how that could happen. Alright, take a look, guys. I have this blue ellipse and this red parabola, and they seem to intersect here, here, and here. So 1, negative 1, 5, 3, and 9, negative 1. Okay, so 1, negative 1, 5, 3, and 9, negative 1. The same three values that we got when we solved this by hand. That is pretty cool. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.